All right, 6.2 general sinusoidal graphs. Our first, or we have two essential questions. So, given a graph of a sinusoidal function, how do you find its equation? Given an equation of a sinusoidal function, how do you graph it? Okay, here's a picture of a sinusoidal function. We don't know what the equation actually is, but we have covered a few things here. One thing is a period, right? So going from, like, for example, the highest point to the next highest point. So completing one entire cycle. Like, how long does it take you to complete one entire cycle? Okay, so that's a period. The sinusoidal axis, I actually call it the midline. So that's this dotted line here. And basically, it is a transformation. So normally, this line in the like sine and cosine functions that we've explored, you've been around the x-axis, right? So you go up 1 and then down to -1, and this midline has been your x-axis. So this midline, or the sinusoidal axis, ends up wherever you have vertically translated the graph. So if you have vertically translated the cosine function 5 units up, then this midline, or the sinusoidal axis, ends up at y equals 5. So the way that you find the midline is just like you would find the midpoint. Kind of think of it as all of these are like the middle of one of these branches. Okay, so the midline is 1/2 of the highest plus lowest. And those are outputs that I'm talking about. So y values. So it's really, the two, the highest and the lowest output divided by 2. Think of it like a midpoint, okay? And it shows you, this ends up giving you the vertical translation. Or the vertical translation will tell you where this midline is going to be. All right, now amplitude is a little bit different. So amplitude is how high above this midline are you and how low above the midline. It should be the same number, by the way. Okay, so amplitude is more like the distance, and it's half of the distance from like the highest point to the lowest point. So to find the distance between these two, we subtract them, and we only want half of it because going from the midline up or the midline down doesn't matter. Okay, and it's always going to be positive. So you're not going to think of like negative amplitude going down. When they're asking for the amplitude, they're asking how far is your highest or lowest point from this midline. So amplitude is really half of the distance from the highest and lowest outputs. So half of highest, this time minus lowest outputs. All right, so there's not a whole lot new here. When you see this, maybe the letters are different to you. But really, there's not a whole lot new. These are all the transformations that we've been talking about since Algebra 2, actually since geometry, but as far as functions go, since Algebra 2. Okay, so the absolute value of A is the amplitude. Like I said, A is not concerned with whether you're going up or down. It's just how far from this midline to the highest point or to the lowest point. And like I said, they're going to be exactly the same. Okay, so A is a vertical dilation. Okay, so A becomes your vertical dilation. That makes sense, right? It's being multiplied to this function. Okay, so this is your vertical dilation. Okay, and and we're thinking right now it's always going to be positive. It's going to be negative if the graph has been reflected over like the x-axis. Okay, so nothing new there. It's capital A. We've always used lowercase a. Okay, B is the reciprocal of the horizontal dilation. Nothing new here either, right? So B is happening to the input, right, to theta. Okay, so it's an inside transformation, and it is a horizontal dilation. And for example, in the past when we've said, all right, this graph has horizontally dilated by a factor of 2, well, really, we multiplied the inside by the reciprocal of 2, so 1/2. Okay, so B is the reciprocal of the horizontal dilation, and I'll show you how to find that in a second. C is the location of the sinusoidal axis. Okay, so we've already talked about that. That's that vertical translation. And I also call this, instead of sinusoidal axis, I call it the midline, because it's just like basically the middle of the thing. And then D is the phase displacement, or that horizontal translation, right? So we've always called that the H, and we've always called the C the K. All right, so when you're thinking about this, if you need to write yourself a note, hey, by the way, C is really K, and D is really H for us. All right, period is broadly defined as the number of degrees per cycle. And frequency, on the other hand, is the number of cycles per degree. Okay, so let's look at, we've got some properties down here. So period, you can really think of this as being 360 divided by this horizontal dilation piece, okay? So we can say that period really is the same as 360 divided by B. And we keep that positive or negative. We're going to keep the absolute value of B. If the inside of the function is negated, that's a reflection across the line or across the y-axis. Okay, so we don't really think about B and A in terms of positive and negative. We think of, if they're going to be negative, if they're going to be opposite of what they should be, then it's a reflection. This would be a reflection in the x-axis. B would be a reflection because B is right next to the input, right? So that would be a reflection in the y-axis, okay? So you can also say then, another way of writing this is that basically the absolute value of B is equal to 360 degrees divided by the period. I think of it a lot like this because I'm trying to figure out what B is. Whereas frequency now is B divided by 360, right? You're trying to figure out how many cycles there are per degree. So it's just the reciprocal of the period. Moving on to the next page. A little review here. So we've got, in a sinusoid function, we've got, a critical point that's a max, a critical point that's a min, and so on. You have concavity, so you have concave up and concave down, and in between there's the point of inflection. What you're going to notice about these points of inflection is that they're halfway between the max and the min. So if they're halfway between the max and the min, they must be on that midline, right? So you can think of those points of inflection on that midline, or it's drawn right here, drawn on that sinusoidal axis, okay? And it's going to be, so the midline is constant where it's hitting this. It's hitting it right in the middle. The high point, they're going to keep coming out at the exact same height. The low points, those are going to keep coming out at the exact same height as well. Okay, so you always have this higher bound and this lower bound. It doesn't, and what I'm trying to say is it doesn't alternate. So for example, right now, these are not gonna, you're not gonna be like, oh, I'm at, 2, and then the next one, oh, I'm down here to -3. On the same sinusoidal function, you are going to be, your high points are all going to be the same output. Okay. Oh, and so what I should say about that then is that these points of inflection, they kind of break up like one period into 4 pieces. So from the high point to the point of inflection is a quarter of that period. Okay, and from the point of inflection to the low point, another quarter of that graph for that period. And then same thing here. So going from the low point back up to that midline or point of inflection, you got another quarter of the graph for that period, and then the last quarter comes from the point of inflection or from the midline to the high point. And again, a period always goes from, I like to choose like the highest point to the highest point, or the lowest point to the lowest point. Sine functions are a little bit more tricky because you're looking at, for example, the sine function goes through 0, 0. So sometimes I'll look at that. When do I get back to 0, 0? Or when do I get back to, go all the way, for example, in a sine function, go up to my highest, come back down to my lowest, and then end up back at the x-axis. So let's do a problem from your textbook. On page 283, number 9, there is a question that says, what are the amplitude, period, phase displacement, and sinusoidal axis location of the graph? And check by plotting on your grapher. And we're actually also going to graph it on here before we check it on our grapher. Okay, so the equation that they're giving us is y equals 6 plus 5 cosine of 3 times the quantity theta minus 60 degrees. So when you're doing these, think about that general equation. Okay, so think about looking at it like this. Okay, so I'm going to go ahead and write that just directly underneath it, so we can figure out all the different pieces. So it's C plus, and C was that vertical translation or that midline. And then you got the amplitude times the cosine of that horizontal dilation factor. And then theta, or your input, minus your phase displacement or your horizontal translation. All right, so let's go through each one of these. Okay, so starting with C. Okay, well again, C was our midline or sinusoidal axis. And so our midline here, well, that's going to end up being at 6. Okay, so this is also our vertical translation. I'll try and name as much as I can for you. Okay, but that's going to be really important. So our midline is at y equals 6. Okay, A is our amplitude. Okay, and that's going to be at 5. So that's going to help me find my highest and my lowest points. I'm basically going to go from this midline, and I'm going to rise up 5 and go down 5, and that's how I know where my highest and lowest points are. Okay, let's see. B, that's our horizontal translation. So basically it's the reciprocal, or sorry, not horizontal translation, horizontal dilation. It's the reciprocal of that horizontal dilation. And so if B equals 3, then that means that our horizontal dilation factor I think I spelled dilation wrong. I always do that. Dilation. I put an A in there for some reason. So horizontal dilation factor is really going to be 1/3. So this means that this graph, you know, with whatever your original cosine graph is, it's really going to be 1/3 as big. Okay. And the last one is our phase displacement, or that's our horizontal translation. And notice it's always, you know, minus d. So if it's minus 60, that means that I've actually moved right 60 degrees. Okay, so this is going to equal 60 degrees, which means I go right 60 degrees. If it had been plus 60 degrees, then I would know that d would be negative. Okay, so let's think about all of these things together. And this is where it gets a bit tricky. First thing I'm going to do is I'm going to graph my midline. So my midline is going to be at 6. Okay, and then I'm going to actually draw in my midline. This is going to help us. So I'll do a dotted midline. Okay, now let's remember what cosine looks like. So your cosine function basically completes an entire period or cycle in 360 degrees, okay? So if this is 360 degrees here, and my midline, let's see, we'll call this, how about x and y? Or I should say theta. My midline right now is the x-axis. I'm just doing the parent graph here. So my highest point would always start at 1 or at 0, 1 on the y-axis. And then I do a quarter of the graph and I get down to my midline. I do another quarter of the graph and I get down to my lowest point, which is at -1. I do another quarter of the graph and I get up to my midline again, and I do another quarter of the graph and I get up to my highest point, which is 361. Okay, and then this is the midway, so this is 180. So again, I've taken this period of 360 degrees and I've divided it up into quarters, right? So this would be at 90 degrees, this is 180, this would be at 270 degrees, 270 degrees. Okay, well this whole thing gets shifted in many ways, and it gets dilated too. First of all, the midline has now been shifted up. Okay, the midline's up at 6. So I know that my highest point then, using my amplitude, my highest point is going to be all the way up to 11. Let's see, 6, 7, 8, 9, 10, 11. And my lowest point is going to be 5 units below, or at 1. So my graph is really just up here in the top. All my outputs will be positive. Okay. Another problem is that I have my B was 3, so that tells me that my horizontal dilation factor is 1/3, which means that this thing has been shrunk by 1/3, right? So it's basically going to take up, instead of being at 360 for one full period, it's going to be 1/3 of that, which is going to be 120 for a full period. Okay, so let's talk about how we figure that out. So my period is always 360 divided by B. Okay, so I'm going to do that right now, which I think we just talked about. So your period is always going to be 360 divided by B. Well, in this case, B is 3, so that tells me that my period is 120 degrees. So in 120 degrees, I have to make up all 4 quarters of one full cycle. Okay, well, what's a quarter of 120 degrees? So a quarter of 120 degrees is 30 degrees. So every 30 degrees, I should either be touching a midline, or a low point, or a midline, or a high point. Okay, so let's try that. So every 30 degrees. So let's see here. This is going to be 30, 60, 90, 120. Okay, so I'm going to start at my high point. Again, this is a cosine function. And it's been displaced 60 degrees. So actually, my high point is going to start at 60 degrees, right? Because this thing has been moved right 60 degrees. Initially, I would have started at 0, 11, but I've been horizontally translated 60 degrees to the right. Okay, so my high point is actually going to start at 60 degrees. And now I'm going to have to complete a period of 120 degrees, which is going to take me to 180. So 30 degrees past 60 degrees would bring me to 90 degrees. That's going to bring me down to the midline. 30 more degrees, right, another quarter, is going to take me to 120 degrees, which is going to bring me down to my low point, which was 1, because that's 5 units less than 6. 5 is my amplitude. Okay, another 30 degrees. And where am I getting these 30 degrees from? I took my period and I divided it into quarters. Okay, so another 30 degrees, or at 150 degrees, is going to bring me back up to my midline. Another 30 degrees will bring me back up to my highest point. Another 30 degrees, which puts me at 210, brings me back down to the midline. Another 30 degrees would be at 240. That brings me back down to my lowest point. Another 30 degrees, which is at 270, brings me back to my midline. Another 30 degrees brings me to 300 degrees, and that's back up to my highest point. And I can keep doing this forever. Why don't I get back to my y-axis so I have a y-intercept? So if I go backwards 30 degrees, if I'm at my highest point here, backwards 30 degrees brings me back down to my midline. Backwards 30 degrees more brings me down to my lowest point. And then, of course, I can go over here to negative 30 degrees, and I'll be back up to my midline. So that's kind of the pattern that you're looking for, right? So think of dividing this thing up into quarters, just like we talked about right here, right? Quarter, 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 quarter. So always divide your period up into quarters, and then go from highest point to midline, or point of inflection, to lowest point to midline, back up to highest point. Okay, so connecting all of this stuff, make it look like a cosine graph. You know, so what I mean by that is it shouldn't be pointy, it should be the sinusoidal. And you can keep going. I mean, if I did another 30 degrees, I'd be here. And then another 30 degrees brings me down to my lowest point. Something like that. And these keep going. The endpoints keep going. It's a periodic function, so it keeps repeating itself. Okay, so let's talk about a couple of things here. First of all, back to some vocabulary. So your cycle goes from, in a cosine function, it's basically the same as your period. Period is just a way of measuring it. But like a cycle would go from this highest point to this highest point, right? I've touched the midline, I've touched my lowest point, I've touched the midline again, back up to my highest point. Okay, so that's a cycle, and it's measured in degrees, and that gives me my period. So going from 60 to 180 degrees, right, from this highest point to that highest point, 60 to 180 degrees gives me 120 degrees. That's how we measure our period. Our period is measured. Basically, your period is like how far have you gone to complete one cycle. Now, the only other piece of vocabulary that we talked about here was your frequency. Okay, and we talked about it's the number of cycles that you can get per degree, right? So I can get one cycle in 120 degrees. So then my frequency here would be 1 out of 120. So we'll just write that frequency then would be 1 cycle per 120 degrees. Or 1/120th would be my frequency. So one thing that you can think about is that if you have a shorter period, you're going to get more cycles that can fit, and therefore you're going to have a higher frequency. And we think about that probably with like noise. Moving on to example 1. Suppose a sinusoid has period 12 degrees per cycle. So your period is 12 degrees. Amplitude is 7 units. Phase displacement, that's that shift, that horizontal shift. So we can call that, I think that was D. D is -4. With respect to the parent cosine function, and we have a sinusoidal axis 5 units below. So I believe that was C. We're going to be 5 units below the theta axis. That's like your x-axis. Okay. Without using your grapher, sketch the sinusoid and then find an equation for it. So the first thing I'm going to want to think about is my period. Okay. Remember, we want to split up our graph. When we graph this, we split it up into quarters. Okay. We're going to figure out where our high point is, and then we're going to go a quarter of the way to our midline, and then we're going to go another quarter of the way to our low point, another quarter of the way to our midline again, and another quarter of the way to our high point. So we have to take our period and we have to divide it up into quarters. Well, that's really easy. If this period they're saying lasts for 12 degrees, then that means that I'm basically going to take 12, divide it up into quarters, which means every 3 degrees I should either be at a high point, a midline, a low point, a midline, or a high point. Okay. Now, my midline is at -5. So this right here is my midline. My amplitude from -5 tells me that I'm going up 7 and down 7. So my highest point, if this is my midline, my highest point, my highest output is going to be at 2. And my lowest outpoint is going to be this minus that, which is going to be -12. Okay, so I'm going to do my best to kind of start graphing this. Oh, and my displacement is not going to start at the y-axis because I've been moved horizontally back 4 units. Okay, so let's see. I'm going to want to be lower than I am higher. And I'm going to want to go a little bit into the negative theta axis. I think I'll go a little bit lower to try and keep this as accurate as possible. Graph paper would be helpful, but I did not give you graph paper, sorry. Okay, so 1, 2, 3, 4, 5 puts me at -5. That's where my midline is going to be. So I'm going to go ahead and graph that, because that's where my C is. I'm going to use a dotted line. I'm also going to go up to +2 because that's going to be my highest point. And this should be -12. 6, 7, 8, 9, 10, 11, 12. I'm going to label my axes because I haven't done that. So this will be my y-axis. And then when we use degrees, we use theta. So my theta axis. Okay, so I know my high points are going to be at an output of 2. My lowest points are going to be at an output of -12. Now the question is, where do I start? Okay, well, again, my horizontal translation is -4. So normally, your cosine would start on the y-axis as the highest point. But I'm going to go back -4. That's going to be where my highest point is. Then every 3 units, right, because I took my period of 12 and divided it up into quarters, which gave me 3. Every 3 units, I'm either going to be, this is my highest point. In 3 more units, I'll be down on my midline. 3 more units from there, I'll be down to my lowest point. 3 more units from there, I'm going to be back up to my midline. 3 more units from there, I'm going to be back up to my highest point. All right, so go 1, 2, 3. I should be on my midline. Okay, so that's a -1, -5. 3 more units, 1, 2, 3 puts me at 2. I'm going to be down to my lowest point, so 2, -12. 3 more units, 1, 2, 3 puts me at 5. I'm going to be back up to my midline, so 5, -5. 3 more units puts me up at 8, and my highest point now. So 8, 2 is going to be a point. I'll do a little bit more. That right there is 1 period or 1 cycle. Okay, and so that's 1 cycle. It goes from my highest point, midline, lowest point, midline, highest point. The period is 12 units. Okay, let's go 3 more units. Puts me at 11. I'm back down to my midline. I'll go 3 more units. And that'll bring me down to my lowest point. So 14, -12 will be a point. And I'm pretty much out of space, so I think I'm just going to go ahead and stop there. I'm going to do my very best to make this look like a cosine function. And it continues on, but I've fit as much as I possibly can on here. Okay, so let's see. Sketch the sinusoid. I did that. And then we have to find an equation for it. Okay, so let's go ahead and let's find an equation. So your general equation for any sinusoid, I'll go ahead and write it up at the top. Midline plus amplitude times cosine of your horizontal dilation factor times your input minus your horizontal translation. Well, I think I have almost all of this except for the b. And let's remember that there's a relationship between period and b. So period is always 360 divided by b. And it's like absolute value of b. B should always be positive. Okay, so if it's not, again, that has to do with reflecting, not necessarily with finding your period or finding your b. So in other words, b then, or absolute value of b is going to be positive, is going to be 360 divided by your period. Okay, so I'm going to find b by taking 360 and dividing it by my period of 12 degrees. Well, that ends up giving me 30. So really what I've done then is I've taken my original cosine function and I've shrunk it by a 30th, right? I've taken a 30th of it, which makes sense because look, like 1 cycle is only 12 degrees. Okay, it makes total sense. Or 1 period is 12 degrees. All right, so we're going to have y equals, well, c was -5. Again, that's our midline. That's here. Maybe I'll make that look negative again. Plus your amplitude, which is 7, which is how high or low you're going from your midline, times cosine of b. B is 30. And then you got theta, and then minus, you got minus d, or minus a -4. I'll write that out, but I'm going to go ahead and simplify it. So -5 plus 7 cosine of 30 times the quantity theta plus 4. Now let's go ahead and let's put this onto our grapher and make sure that our graph looks similar to what we get on our grapher. Now, first of all, make sure that you're in the degree mode because we are using degrees, right? We've got theta here. Okay, back here. Making sure that my window is appropriate. You know, I want to go down to -12, up to +2, -4, maybe to 14. So my window, sure, how about we go X max is 15. I think my Y minimum should be less than -10. So let's go, how about -15? I don't really need a Y max of 10. So let's just go up to 5. And I can check some of these points. For example, this low point is 2, -12. So I could calculate a minimum, make sure. I could also trace it. So I got, well, that's really close to 2, -12. So that totally checks out. Moving on to example 2, we're going to, let's see, for the sinusoid in this figure, give the period, the frequency, the amplitude, the phase displacement, and the sinusoidal axis location. Okay. Let's start with our period. So I notice that this thing goes from its highest point, once again to its highest point, after going to its lowest point and touching that midline twice. I notice that it's from 3 to 23. So I believe that the period is 20 degrees, which then tells me that my frequency is the reciprocal of that, 1/20th of a degree. From there, we can figure out what our B is. If we want to write the particular equation, we're going to actually need B. So B is 360 divided by the period, which is 360 divided by 20. So B gives me 18. I can find my phase displacement or my horizontal shift rather quickly. Normally, this highest point for a cosine function would be right on the y-axis, but it's been moved over 3 degrees. So that's D, that phase displacement. I know it's been moved 3 degrees to the right. My sinusoidal axis, okay, or what I like to call is the midline. Okay, so that sinusoidal axis is C, and that's where we find the midpoint. So it's like 1/2 of the highest point, which is 56, plus the lowest point, which is -38. So you actually get 1/2 of 18, which is 9. Get on the paper here for you. And the only other thing we need to figure out is our amplitude. A couple ways you can do that. Now that you know that this is 9, then you ask yourself, well, how far is it up to 56? That ends up giving you 47. Or, like I had given you originally in the notes, it's 1/2 of the highest output minus the lowest output. Well, when you do that, you get 1/2 of, what does that give you? 494, which is 47. Okay, so a couple ways that you can think of doing that, but we're going to go ahead and keep using little formulas. That'll just make life easier for us, but you can also, once you know this, you can just say, well, 9 plus what will give me 56? I think that's all we need. So now we're going to go ahead and we're going to write our equation. So the general form for a sinusoidal using cosine would be C plus A cosine B theta minus D. Our midline, C, ended up being at 9. Our amplitude was 47. Our B we found to be 18. Theta minus, and our horizontal displacement ended up being 3. This is our final equation. How can you check it? You can graph it on your grapher and make sure that it works. Last example, example 3. Figure 6-2i shows a quarter cycle of a sinusoid. Write a particular equation and check it by plotting it on your grapher. Okay, so we've got a quarter of this. Now, it looks to me like I am currently on a concave up, okay? So my point of inflection is here, which means prior to that, I was on a concave down. So sometimes it's helpful to graph these. Concave up means I'm at here I'm down to my lowest point. So I'm going to come back up to that midline, point of inflection, and then I'm going to go back to concave down. Right, so each of these is a quarter. I know my drawing is probably not fantastic. Some of you guys are way better at this than I am, so I encourage you to have nice, neat drawing. But we know that, basically from here, from what we were given, that piece was a quarter. Well, that piece was 7 degrees, which tells me that my period would be 7 degrees times 4, right? Because 7 degrees was a quarter of whatever this is. So my period then is 28 degrees. So going backwards another quarter, another 7 degrees is going to be 10 degrees. Forward 7 degrees, that's 31. And then up here, let's see, 38. We know that my midline is going to be at 8. So that's going to give me my C. Now the question is, what's my amplitude? Well, amplitude, so it looks like from 8 to 3, so that looks like my amplitude is 5. So that's pretty easy, which tells me that my highest point then should be 13. Not that that's important for putting this into an equation. The fact that my period is 28 is going to help me find my B. So B is going to be 360 divided by your period. Oh, let's see what that gives us. I think I'm going to leave it like this because I end up getting 12.857. So instead, maybe we could just reduce it. Let's see, 36 and 28 can both be divided by 4. So I get 97ths. I think that's going to be the best way to write this. All right, let's see what I'm missing here. So I got y equals c plus a cosine of b theta minus d. Phase displacement might be helpful here. So it looks like my highest point is over here at 10. So we can say that this whole thing was shifted 10 to the right. So that's going to be my D, which is 10 degrees. Now, I mean, there's a million different ways to do this. You could say it was shifted actually, let's see, 40 degrees. You could say it was shifted a whole bunch of different multiples of this 10. So it's going to really be difficult when I grade these because you're all going to maybe come up with different types of equations, okay? But just to make this the simplest in my mind, I've got a period going from 10 to 28, or sorry, from 10 to 38, a period of 20 degrees, 28 degrees. So I can say, hey, originally it was up here, my highest point, and it's been shifted to the right 10 degrees. I'm going to use 97ths. And we will do this with radians as well. So it's good that you put the degrees there. That way you know what you're working with.